Now let's look at rule 2 of integration. Now we are interested in integrating a function fx raised to the power n and multiplied by f dash x. So the function we want to integrate is f dash x times fx raised to the power n with respect to the variable x. So the result states that if we want to perform this integration, the answer to the left hand side is the function fx raised to the power n plus 1 divided by n plus 1 plus a constant. So I think it is important to observe the terms on the left hand side and the right hand side of this equation. So we are integrating f dash x times fx raised to the power n with respect to the variable x. The answer is fx raised to the power n plus 1 divided by n plus 1 plus a constant. Note well, this result is applicable for n not equal to minus 1. So here we see a product 3 multiplied by a term in the bracket squared. So if we choose this term inside the bracket as fx, so we can see fx being raised to the power 2, and the derivative of the term colored in red is 3. So what we see here is f dash x. The term colored in red is fx. The term colored in yellow is f dash x. And our general result states that f dash x times fx raised to the power n, so n here is 2, is simply fx, which is the term colored in red, raised to the power n plus 1, so n is 2, n plus 1 is 3, divided by 3 plus a constant. So let's look at another example. Here we have a function fx being raised to the power 6. Derivative of the function fx, in other words the derivative of the expression colored red, is 5. So this term that is colored in yellow is f dash x. So now we can apply rule 2. So f dash x times fx raised to the power n is fx raised to the power n plus 1, n is 6, so n plus 1 is 7, divided by n plus 1 plus a constant. So let's look at another example. Here we've got a function raised to the power 6. The derivative of this function also appears as a product. The derivative of the function or expression that is colored in red is 10x. So that also appears as a product. So we have f dash x. Fx is the term colored in red, and fx is raised to the power n. So according to rule 2 of integration, we have fx raised to the power n plus 1, n is 6, so n plus 1 is 7, divided by 7 plus a constant. So let's look at another example. Here we have a function raised to the power 2. So this is a function 3x plus 1 marked colored in red, raised to the power 2. Now if we differentiate the function colored in red, the derivative of the expression colored in red is 3. Now we don't see 3 as a product, but that doesn't still prevent us from integrating. We can place a 3 out here, and since we multiplied the whole expression by 3 to make the expression unchanged, we have to divide it by 3 as well. So multiplying by 3 and dividing by 3 does not change our original expression. So now we have fx colored in red and f dash x as a product, which is 3, and we could apply rule 2 to write the answer to this integration. So the term 1 on 3 will remain unchanged. Now we have f dash x here, we have fx here, raised to the power n, n is 2. So according to rule 2, we have the answer fx raised to the power n plus 1. So n is 2, so n plus 1 is 3, divided by n plus 1, which is 3, plus a constant. So this can be simplified further. So it will be 3x plus 1 cube divided by 9 plus a constant.